Okay, hello everyone. This is Aaron Rababaah, and I will be given a demonstration of our simulator, wind turbine simulator, which is actually a software designed to simulate a wind farm of 50 units or 50 turbines. So this is actually created under MATLAB software. So let's actually go ahead and start the session. I will try to make it as short as possible, but of course given the enough details as we go. We start, MATLAB is running already. The simulator is run by the command WT _sim. That's the wind turbine simulation or simulator, and initially it comes like that with of course no data shown, only the control panel to the left. This is the first area we will talk about, control panel, which has the different components that configures and initializes the simulator. In the middle here we will see actually the data being pulled and displayed on 50 different plots or charts or figures. And to the right we will talk about the warning scale. That is a color-coded scale of the severity of the detected defect. Let's basically the simulator works by randomly generating 50 different models of the data that we have. We have a multi-gig data representing healthy data and basically damaged data, and then from these we pull different random samples to generate the 50 different turbines. So let's talk about the different control components here that configures and initializes the simulator. First of all, we'll talk about the initialize. The initialize button here, as you can see highlighted here, it actually will create the 50 turbines represented by their figures, which the data will be actually populated or presented or displayed on each figure. Okay. Now. Yes, so yeah, we continue talking about these components. The time delay basically sets the sampling frequency. That means how many samples you want to pull from a turbine per second. And the sample is really a chunk of data. It's not like one data point, one reading. No, it's a 1 kilobyte of data every time. How many kilobytes you want to pull from that signal, that particular sensor. So that's the time delay. And after really experimenting with this, 3 seconds is enough, just to give the simulator enough time to process this 50. I would be 3 seconds would be fine. We can decrease, increase, but I don't recommend going below 3. It would actually create a problem. Next, we talk about these two buttons where we have a process off or run off. The process off is that you want to turn on or disable the processing because you have two modes. You can just display the collected data, or you can display it and process it at the same time. So these are the two modes that we can actually switch between. Also, the other button, run off, you can basically just start the simulator. We'll start pulling the data, processing, and doing the rest of the things that we talk about. But this button is just to start the simulator. Now, we will talk about these later when we see the data actually there, but let's talk about two other components here right at the bottom. It says failure rate factor and then snowball factor. What these about is, the first one is actually the likelihood that a turbine would have an event or anomaly or a defect, right? That means we're setting the factor. If you increase it, then there is the likelihood will increase, will be more for any turbine to have a problem or have an event. If you decrease it, of course, the likelihood will decrease. So we control, these factors based on our needs. Now, for this simulator, we have to make it really high, so we can see actually some, something happening, rather than to wait a long time to see an event. So we make, let's say, 90% of the time, yes, I'm expecting to see an effect, but that's not normal. I know. But in a simulator, we have to, control the speed of the events, so we can accelerate the process, so we can see events happen, how they actually happen, and how they are represented, and how they are reported, etc. The other one here is a snowball factor. What a snowball is? It's a fact in failure modes when, and this is in any actually structure or any machine. If a machine has a problem, it tends to have more problems as you go. If you don't do maintenance, if you do not do maintenance, then it's going to actually escalate and it's going to snowball. Right? So a little problem causes more problems, which causes more problems and bigger problems. That's what the snowball is. So it's again another factor that is going to give us interesting results. So once you once a turbine exhibits a certain failure, then if you don't do maintenance, then it's going to actually escalate and then snowball from that and increase the severity of that failure. Okay, so with this we can start, and then we talk about later on about these, because they are related to the data that is represented by the samples we are pulling from the. Okay, now let's start actually the simulator, and then we say process on and run on. Okay, as you can see here. Okay, so first let's initialize. I forgot to initialize to populate. So once we populate the different in this area, of course, the 50 turbines will be created, and each of them would be actually pulling different data from representing the different turbine. So as you can see here, for each figure, we can choose which signal we want to present or plot or process. So we can choose the different sensors, speed and torque, and the different sensors are located on the body of the turbine. Now we can do them individual like that, or if it is taking too long time, we can say randomize here. Rand sensors. Look at this button here, which allows you to basically randomly select a different sensor for a different turbine. As you can see, if I keep doing that, it randomly generates or selects as you can see, these are changing. Look at this area, how these AN4, AN6, the selected signal is changing all the time, as you can. And then we can stop at a certain point that, okay, we're fine, let's do this. Once we select that, we can actually also come back to the initial situation by saying, no, I want all the turbines to be uniformly collecting AN7, and all of them would come back, as you can see, AN7. Or I change my mind and say, okay, all of them I need to be pulled speed. I want to see the speed reading from all of them. Or I need to see something else, maybe torque. Or I'll come back to AN3, and so on. But random would be actually, randomly would be better, interesting or more interesting to see this. Okay, so let's stick with this. And The snowball, so we didn't forget to do the snowball, so we have a high, so we can see interesting results as well. I think by setting up all these parameters, we are ready to run, right? We are ready to run the simulator. Here we go. Okay. And watch how the different turbines are displaying the current actually signal, and also watch if some of them started to actually pick up some problems, and look at the background of the figure. The background of the figure is actually relating to this scale, severity scale, right? The dark blue is actually normal, light blue is actually has more problems, and you can go up the scale until through the green, through yellow, through orange, through the red and dark red. This is where the most severity would have. So if you see a turbine that has actually the color is reaching to the red or dark red, then it has more problems. But the closer to the dark blue, then it is normal, right? And let's talk about different also components here. This black screen actually dynamically displays any event that happens. So, for example, this one here, number 22, damage data at time such and such. Turbine number 27, damage at such and such. So it's reporting, as you can see, the different events. And look at the colors now; they are basically changing as the severity is changing per turbine. And when I talk about this actually plot to the left, this one is actually showing you exactly the same data, only in a bar chart. So every turbine from 0 to 50 here, from 1 to 50 is showing you the accumulated number of defects it has actually recorded. And the last figure here showing you accumulation of this bar chart, so by time. Okay, so time 0 it was, let's say, 5 defects. Time number 10 it was 20. Time number 50 it was, let's say, 130, and so on. So this accumulation, this plot is accumulation of actually the bar chart there, and you can see actually how the different colors is displaying the different severity per turbine. And it will actually keep going like that until some of them, like this one, for example, number 42, reached a very actually red area here, and different ones can see. And you can actually stop anytime to just not process, and you can stop it. And once you stop that, there is a button right here, Save Database, where all these recorded events will be saved or archived into database. So let's do that, and we'll see the resulting file will go as we will display it. Now the software is actually saving all these events into a database. It's actually an Excel sheet with the rows and columns that per each event, it records the sequence number, the turbine number, the time of the signal, the sensor, the location of the sensor, and the severity of that event based on the color as we saw here. Okay, and then let's go to that file and see. Let me open that actually directory. Is WT excuse me, and then this is our file. I'm going to try to open it, but if it's not done, it's going to have actually access conflict. But if I open it until it's ready, I can't open it actually. But I'm going to try. Okay. So let me try to open that Excel file. Yes. So obviously it has finished, right? It has finished, and we can go from the beginning, and we will see that event number, time, and we can. This is actually ticks. That means it's a part of a second. We can convert it into seconds, minutes, hours, whatever we want. But this is why ticks, like the CPU time. turbine number, this column. So this is event number, time of the event, turbine number that actually have that problem at that time, and then the sensor, which sensor actually reported this data failure, and then the location of the sensor on the structure of the turbine, and the severity, as you can see, is color coded. So you can look at the, let's say, event number 46. The time of it is 16 or 162,000 something, and then turbine number 27, and then AN6 is the location or the sensor name, and then the location is basically here, stated here. There's of course a key what the location is called. We have to show the diagram that actually specify the locations of the sensors, so that's not a problem. And then the severity is 16, and can go up to, let's say, 100, up to 100. So, and then we can scroll down, see the different events and different turbines exhibiting these different ones. Okay, so this is the database that we recorded, archived. It has actually about, as you can see, 150 or 165 events. Of course, we will never have this in a real life, but we accelerated to see some interesting, actually. If this, maybe it can happen in 10 years or 5 years or whatever, but we would like to see accelerated events to see some interesting results. And finally, we come here and then close this, and of course we will by this we end this short demonstration, and I hope that we have accomplished a good step toward finalizing the final stage of the project. And I will be waiting on your feedback, comments. What do we need to do? Is this good enough, or do we have more stuff to add or to change or modify? All for your comments. I'm waiting for your comments and feedback. Maybe we can have a meeting some time soon to discuss this video. I'm going to send this video to you, and then we have a discussion about it. So thank you for listening, and we will looking forward to discussing this with you. Thank you.